last class we actually stopped at this point. So what is, if T of n is number of times algorithm is displayed when n is supplied as input, then give a recurrence relation for T of n. What is recurrence relation for T of n? If n equal to 1, how many times algorithms is displayed? If n equal to 1, how many times algorithms is displayed?
One time.
Only one time. So T of 1 equal to 1. If n is more than 1, that means if n is greater than or equal to 2, then else part is executed. In else part, for each value of I, from 1 to n, one time it is executed or not? For each value of I, 1 to n, one time it is executed or not? That means it is n. So n times this algorithms is displayed. After that, again we are calling the same function with n minus 1 as input. That means what is the time for this? T of n minus 1. So therefore, if n is greater than or equal to 2, what is the number of times this is displayed? N plus T of n minus 1. Then how to solve this reconciliation? Again, we can apply substitution method. T of n is T of n minus 1 plus n. What is T of n minus 1? What is T of n minus 1? T of n is T of n minus 1 plus n. What is T of n minus 1? Wherever n is there, substitute n minus 1. So what is that we get? What is T of n minus 1?
T of n minus 2 plus n minus 1.
That is n minus 1 is important. Okay, no? Wherever n is there, we need to replace with n minus 1. So T of n minus 1 is T of n minus 2 plus n minus 1. Okay, plus n minus 1. So this is the thing that we replace with this. So already plus n is there. Now what is T of n minus 2? What is T of n minus 2 now? It can be written as T of n minus 3 plus n minus 2. Is that okay? Is that correct? Is that correct or not? Plus n minus 1 plus n is already there. Now what is T of n minus 3? What is T of n minus 3? What is T of n minus 3? It is same as T of n minus 4 plus n minus 3 plus already whatever is there, this. Now we can generalize this, no? If n minus 1 is there, we have a term only n. If n minus 2 is there, we have n as well as n minus 1. If n minus 3 is there, we have from n down to n minus 2. If n minus 4 means we have n down to n minus 3. So in general, if it is T of n minus I, then what is the value that we will have? What is the value we have here? If it is T of after I steps. After I steps, what is the value that we will have?
N minus I plus 1 to n.
N minus
I plus 1.
N minus, if 4 means here we have 3, no. So this I can write it as I minus 1. N minus 1, no brother. N minus I minus 1.
Without brackets, sir.
Up to n. Is that okay? Is that okay? Now it is same as T of n minus I plus n minus I plus 1 plus and so on n. I have not done anything, only same thing I have written. But what is the value that we know here? We know only T of 1 equals to 1. So this n minus I place, if it is 1, then we know what to substitute. N minus I equal to 1 means, what does it mean? It implies I equals to n minus 1. So at I equal to n minus 1, at I equals to n minus 1, what happens to this? T of n is T of n minus 1 plus n minus 1 plus 1 plus and so on up to plus n. What is this? T of 1 plus, what is this value? Can we write it as 2? Is that okay? What is T of 1? Which is same as sum of first n natural numbers, n into n plus 1 by 2. So therefore T of n is n into n plus 1 by 2. What is order of growth of T of n? What is order of growth of T of n? What is order of growth of T of n? What is order of growth of T of n? What is order of growth of T of n? It's a n into n plus 1 by 2 means it is n squared, no? So therefore we can say that, therefore T of n is theta of n squared. Is it clear or is there any doubt? Is there any doubt? Is there any doubt? Okay. Now, instead of this, if I am counting what is the number of times n equal to 1 operation is, this comparison is performed, what is the reconciliation? If n equal to 1, how many times it is performed? How many times this comparison operation is performed? N equal to 1? One time. If n is not equal to 1, one time already we performed here. So that's why 1 plus. Again recursive call. Here there is no such thing. Here again recursive call. For this it will be T of n minus 1. What is answer we get here? What is answer we get here? What is answer we get here? It is n. Is that correct? But if what is running time of this algorithm? Now you please tell me. What is running time of this algorithm? What is running time of this algorithm? What is the running time of this algorithm? Order of growth is n or n square?
N square.
Is it n or n square? Is it n or n square? Is it n or n square? That means whichever operation is performed more number of times. So this is performed more number of times. Hence, it's a running order of growth is n square. Its order of growth is n square.
N square.
It's n square, no? Is it n? Can you say that its running time is n?
No,
That is not correct. That is not correct. So actually, if at all you have any confusion, you can do it for each and every step in the algorithm. Each and every step in the algorithm. So how many times this operation is performed? N equal to 1 time. Otherwise, it is what is the most amount of work done here? It is n times. This is also n times. So this is T of n minus 1. Here it is overall it is some constant 1. So you can add up all these things. T of n minus 1 plus n plus n plus 1 plus 1. Then you will get a reconciliation. You solve that. Whatever be the running time, same thing is the final running time of this algorithm. So we don't want to do that. That's why what is that we are doing is whichever operation is performed more number of times, that we are counting, so that its order of growth is same as overall order of growth. Is that okay? Is that correct? Is that this is based on this? We should not say that its running time is n. That is wrong. Its running time is actually n square. Order of growth is n square. So T of n is theta of n square. What about this? So directly you tell me again here as usual, T of n is number of times. What is most important operation here? Again the same thing, no? Number of times algorithms is displayed. Algorithms is displayed. Now tell me, when n equal to 1, how many times algorithms is displayed? When n equal to 1. If n equal to 1, T of 1 equal to 1. If n is greater than or equal to 2, how many times it is displayed? We actually go to L spot. L spot, how many times algorithms is printed? Similar to previous case. How many times it is printed? First, n times it is printed. So T of n can be written as n plus. Again, we are calling the same algorithm, but only parameter is different. Here earlier we had n, now it is root n. What is the time for this part? That means how many times in this algorithm it is printed? T of square root of n. T of square root of n. Is that okay? Is that okay?
Okay, sir.
Okay. Now again we need to solve this reconciliation. Okay. So if you want, we can solve it. Otherwise, there we will be discussing direct methods to actually find its order of growth. We can even use that method. Okay, let us see at least some steps in this algorithm. T of n is T of root n plus n. How to solve it? Again, if I substitute no, then it becomes what? T of root n. Again, if I substitute, it is T of square root of n. That means it is a bit difficult. No. So that's why what is that we can do is assume that n equal to 2 power k. Where k is, this we have already done, no, same thing. K is greater than or equal to 0. Then what happens to this? T of 2 power k equals to root n, means we can easily write it as 2 power k by 2. Is that correct? Plus 2 power k. Now let S of k equals to T of 2 power k. Then what happens to equation 2? Sorry, it becomes S of k equals to what is T of 2 power k by 2? What is S of T of 2 power k by 2? If S of k is T of 2 power k, what is T of 2 power k by 2?
2 T raised
k by 2.
2.
S of k by 2.
Thank you, brother. Thank you. S of k by 2. Is that okay? Okay. See, S of k is T of 2 power k. What is S of k by 2? Wherever k is there, k by 2 we substitute. Same thing, similar thing we discussed in previous class also. No, wherever k is there, k by 2, 2 power k by 2. So in place of T of 2 power k by 2, what is that we can substitute? What is that we can substitute? S of k by 2 plus 2 power k, no change. Is that okay? Now keep doing like this. Keep doing like this. Now again, what is S of k by 2? What is S of k by 2? Yes. See, S of k is now, this is our new recurrence relation say. S of k is S of k by 2 plus 2 power k. Now what is S of k by 2? Wherever k is there, you substitute k by 2. What is S of k by 2? S of k by 2 plus 2 power k by 2. Is that okay? Is that okay?
Yes, sir.
So then it becomes S of k by 2 by 2 plus 2 power k by 2, 2 power k by 2. But again, what happens to this? S of k by 2 square plus, oh sorry, this also we need to, this 2 power k we forgot, no? 2 power k is there, no? Plus 2 power k by 2 plus 2 power k. Is that okay? Is that okay? Because even if we expand, no, directly, I think this sequence finding answer for this, no, it becomes a bit difficult. Okay, again, if you expand, what is that we get? S of 2 by k cube plus 2 power k by 2 square plus 2 power k by 2 plus 2 power k. It goes like this. It goes like this. Is that okay? Is that okay? Is that correct?
Yes, sir.
Now tell me what happens after I steps. I don't know whether you are getting or not. Okay, even if you don't know this, still it is fine. This type of recurrence relations, we will be seeing direct method how to solve, how to find its order of growth. Okay. I just, okay, now stop here. I move to next thing. So you tell me after I step, what happens? After I steps, what happens? This is we are solving for S of k. After I steps, what happens?
2 of k raised to k by 2 raised to minus 1.
2 power I minus 1. Is that correct, brother? Is that correct? Is that correct?
Yes,
Plus
sir.
unswan plus unswan 2 power k 2 power k is that okay? Now what is the value that we need to choose for this? Say assume that what is the value that we know here?
T of 1.
What is S of what is S of 1? What is S of 1? T of
1. So 2 power 1.
T of
2 power 1.
T of 2. What is T of 2? T of 2 power 1, which is same as
2 plus
T of 2. What is T of 2 value? What is T of 2?
2 plus T of root 2.
What is T of 2?
N plus.
Again, you may get here we need to take exactly, if you don't assume n is not of the form 2 power k, then we need to take either floor or ceiling. Otherwise, we don't get integer. Otherwise, we don't get integer there. We don't get integer there. So this is again some constant I can take.
Sir, can we
What
take S of 0, sir?
S of But S of 0 we don't get here, no brother. How to get it?
Only positive.
How do you get? Why I have not taken S of 0? Is it clear, brother?
Yes, sir. Yes, sir.
So S of 1, it is same as T of 2. What is T of 2? Here 2 T of 1, that is 2 plus 1, 1. Can we write it as 3? Is this correct? T of 2 is 3. Is that correct? Is that correct? T of 2 is 3.
Yeah,
Is that
yes,
correct?
yes.
Okay. So
Yes,
now
sir.
K by 2 power I, we can take it, it should become 1. That means what? 2 power I equal to K. That implies what? I equal to log K base 2. I equal to log K base 2. At I equal to log K base 2, at this value of I, what is S of K? S of K by 2 power log K base 2 plus K by 2 power. Why this is only I minus 1, no? Correct, no? This is I minus 1, not 2 power I minus 1, no? 2 power I minus 1 only, no? It is K by 2 power I minus 1, correct only, no? Two power K by 2 square 2 cube. I think this is correct only. What? 2 power I
That is
minus
correct
1.
only, sir.
That is correct only.
Yes.
That is correct only. 2 power 2. Okay, 2 power I minus 1. So what is this we get here? 2 power log n base 2 minus 1. Is that okay? Plus and this one plus 2 power. Sorry, this is only K, no, 2 power K. 2 power K. Is that okay? Okay, if you know this, we can erase. This is 2 power K1. This is 2 power K. Is that okay? So this is nothing but what is this entire value? K and 2, if we interchange, then K comes here. K power log 2 base 2. Log 2 base 2 is 1. K power 1. K gets cancelled. This finally we can write it as S of 1. Is that okay? Is that okay? Is that okay? Is it clear here?
Yes, sir.
Okay. S of 1 plus this entire thing. What can you say about value of this entire thing? S of 1 is constant. S of 1 is constant. What can you say value of this entire thing? This entire value, whatever we get up to this, can you say that it is less than 2 power K? Is that correct? Is that correct? Is that correct? Is that correct? Is it correct or not? See, 2 power 0 plus 2 power. Okay. Do we know that it is 2 power K minus 1? Is it less than 2 power K or not? Okay, instead of K, let us take here. Is it less than 2 power L or not? 2 power 0 plus 2 power 1, 2 square plus 2 power L minus 1. Is it less than 2 power L? It is less than. Why? Because this entire value itself is 2 power L minus 1 here. Are you getting? see, we have 2 power k. All these terms are smaller than 2 power k. Like that, how many terms I have? How many terms we have here? How many terms we have here?
L minus
How many
1.
terms?
N minus 1 terms.
Yeah, n minus 1 terms. How many terms we have here?
If it is
Sir,
k,
k
then
minus 1 term.
Oh.
k minus 1.
K minus 1 or n minus 1? Is it k minus 1 or how many terms here? This one, if I consider it as 2 power 0, 2 power 0, I think this is only k minus 1 terms, no?
Sir, k minus 1.
Can we write it as less than or equal to 2 into 2 power k? Less than or equal to 2 into 2 power k? Is that correct?
Like that.
Hmm?
Yes, sir. It is less than 2 power k plus 1.
Less than 2 power k plus 1. So that means finally what is its value? 2 power k. 2 power k. So therefore s of k, is the calculation correct here or mistake? I think it appears to be correct only, whatever I calculated here. S of k is, we can write it as less than 2 times 2 power k, that is 2 power k plus 1. 2 into 2 power, what is k? S of k is less than 2 power k. 2 into 2 power k. What is S of k? Which is same as t of 2 power k, no? T of 2 power k is less than 2 into 2 power k. What is t of 2 power k? T of n. It is less than 2 into n. Is that okay? 2 power k is n, no. Then therefore t of n can be written as big O of n. Is that correct? Is that correct? Is that correct or not?
Sir, one doubt, sir. Here,
Okay, T of n is big O of n. 1 second, I think this simplification is not. Here itself we are doing a n amount of work, no? Here this simplification must, I think I must have.
sir, that S of 1 we did not calculate now, sir.
S of 1 is constant only, no brother, it doesn't matter. S of 1, that I can call it as 2 square, no.
By calculating order of growth, it doesn't matter.
It doesn't matter, no, it is only constant,
Yes,
no
sir.
brother.
Okay, sir.
Is that any mistake in this calculation? S of k, here, this simplification, is there any mistake? I don't think any. I don't think any, I could not find any mistake here. Only if at all there is something, then here I think probably we need to simplify properly. But the procedure is this. Procedure is this. Is it okay? Is the procedure? But this is lengthy. We need not do all these things. Direct methods we will be discussing. If the recurrence relation is of this form, how to find, How to find its order of growth. Its order of growth. That we will be discussing. Okay, that we will be discussing later. Now, similarly, this algorithm, if T of n is number of times algorithms is printed, algorithms is displayed, algorithms is displayed, then what is T of n? T of 1 is what is T of 1?
It is 1.
What is T of n? If n is greater than or equal to 2,
T of n square plus T of plus.
T of n minus 1 plus n square. Okay, anyhow, we have written here. Okay. Now, can you directly tell me what is answer in this case?
N raised to 3, n to the power 3.
Thank you, brother. Here it is very easy to simplify, no?
Yes, yeah, it is. Right.
This becomes what? N minus 1 plus whole square plus n square. Next it becomes n minus 2 whole square plus n minus 1. Now you can tell me no general pattern. After I steps it is. After I steps it is. Is that okay? Is that correct? Is that correct?
Yes, sir.
Okay, this is only recurrence relation solving. Okay, now that you can please practice how to solve recurrence relations. So now, but what is the value we know as initial conditions? T of 1 is 1. How to get 1 here? N minus I equal to 1. That implies I equal to n minus 1. So at I equal to n minus 1, what is that we get? T of n is T of n minus 1 plus n minus 1 minus 1 whole square plus on this 1 up to n square, which is nothing but T of 1 plus what is this? 2 square. Next is 3 square. Next on this 1 up to n square. What is T of 1? We know that it is 1. So 1 plus 2 square plus 3 square, it is like this now. What is this? Sigma I equal to 1 to n I square. What is sum of squares of first and natural numbers? What is sum of squares of first and natural numbers? Sum of squares of first and natural numbers?
Plus 1 by 6.
N into n plus 1 into
2n plus 1 by 6.
2n plus 1 by 6. Correct, no? What is
Yes.
order of growth? Now directly tell me order of growth. What is its order of growth?
Cube.
N cube. Once you know order of growth, then we can say that T of n is big O of n cube or theta of n cube are also correct. Is that okay? Procedure is like this. Procedure is this. Some recurrence relations it may be easy to solve. Okay, no, some recurrence relations it takes time. Okay, but in competitive examinations, we don't actually solve in the exam, no, the type of recurrence relations. We should have some shortcut way of solving, okay, no, finding its order of growth. Okay, no, finding its order of growth. For that, it is better at least if that shortcut ways, if we forget using this method, somehow we can find what is its order of growth. Okay, this is about analysis of non-recursive as well as recursive algorithms. General procedure. Now, next we move on to some sorting algorithms. So, what is sorting problem? What is input? What is output? Input is a sequence of n elements, A1, A2, An. What is output? A permutation of these elements such that first element is less than or equal second element is less than or equal this, and this one less than or equal last element. Okay. Now, this is what is this order called? Okay, if we have something like this 8, 4, 10, 4, 9, this is input. If my output is, what is output? 4, 4, 8, 9, 10. Is it increasing order? Is it increasing order?
Yes, yes, sir.
Or to be more specific,
Non-decreasing, sir.
Non-decreasing order.
that is next element is greater than or equal to previous element. Next element is greater than this side, and this side if we take next element is either more than previous element or equal. That means definitely next element is not small. Next element is not smaller than previous element. Not smaller than previous element. Previous element. So this type of ordering, this is actually sometimes known that like this. So in textbooks they write it as non decreasing order. Is this correct? Non decreasing order means next element is not smaller than previous element. That means next element may be same as previous element or even more than previous element. Similarly, what does non increasing order mean? Non increasing order.
Decreasing order.
It is if all elements are distinct,
Yeah,
that is same. Otherwise, for example, 10 non-increasing, non-increasing. That means 10, 8, 8, 7, 5, 5, 3, 3, 2. Is it non-increasing order? That means what? Next element is not
Definitely decay. Yes, no.
larger than previous element. That means what? Next element may be here in this case, next element is smaller. In this case, next element both are equal. This side it is smaller. Correct now? Next element is smaller than previous element, or it may be same as previous element. That is called non-increasing order. So that here usually what is output here? Whatever we get, it is non increasing order. Is that correct? Non-increasing order. What are specific values we give to input? That becomes instance. This is an instance. What is value of input size? Input size here. What is input size here? Usually denoted by n. That is 6 number of elements given to us to sort. Is that clear? What is input size? What does non-increasing order mean? What does non-decreasing order mean? Is it okay? Okay. Next. So, how does this selection sort algorithm work? How does it work? How does it work? Okay, let us consider these elements in an array. Please, all of you read the step explanation given. So how does it work? So if this is array, what is that we do? First, we consider smallest element in this array. Consider smallest element. So give me an algorithm to find smallest element of array. Smallest element of array. Algorithm, smallest element of array. array name is say A, and there are n elements. So how to find smallest element? How to find smallest element? First element we can see it as smallest element or not? First element we can see it as smallest element. Is that okay? Smallest is A of 1. Is that correct? What is the next thing that we do? We compare that with next element. We compare that with next element. Then if next element is smaller than whatever, every time we keep track of smallest element, next element is smaller than whatever smallest we have, then we update smallest. We update smallest. Like that for all elements in the array we need to do. Is that correct? Is that correct? That means what? How many elements are there? This is position 2 to position n. Is that correct? Position 2 to position n.
Sir,
Hey, you know this, no? Or do you want me to elaborate on this?
yes, sir.
Okay. So first smallest is, okay, that also I'll explain. Smallest is A of 1, that is 87. Okay. Next we compare. Next element is, say I'll take one variable, I equal to 2. Next element. What is the element at A of I position? We'll check whether it is smaller than smallest or not. If it is smaller than small, what is A of I here? A of 2. What is A of 2? Is it smaller than smallest or not? What is A of 2? 43. Is it smaller than smallest? Is this true? Is that true? Is that true or not? Yes. If it is true, that means what is smallest now? What is smallest? What is smallest? Smallest we change as A of I. Is that okay? Again, we'll increment I. We go to I equal to 3. Now what is? We'll check whether A of I is less than smallest or not. Is that correct? What is A of 3? Is it less than smallest or not? What is A of 3? What is A of 3? 66. Is it less than smallest? What is smallest? What is smallest? What is smallest now? 43. Is this correct? No. If it is no, then we'll go to next element. We don't update smallest value. We go to next element. Are you following? Again, A of I less than smallest or not, we check. What is A of I here? A of 4. What is A of 4? What is A of 4? 88. Less than smallest. What is smallest up to now? 43. This condition failed. So we go to I equal to 5. What is A of 5? A of 5 less than smallest or not, we check. What is A of 5? 27. 27 less than 43. Condition is true. What is new smallest? What is new smallest? Is A of 5 in this case. That is nothing but 27. Again we'll go to I equal to 6. I equals to 6. I equals 6. Then we'll check whether A of 6 less than smallest. What is A of 6? 32. Is it less than smallest? 27. No. So we go to I equal to 7. I equal to 7. What is A of 7? A of 7 is 15. Is it less than smallest? Smallest is 27. Yes. That means what is our new smallest? A of 7, that is 15. Is that correct? Is that correct? So now I value we have taken from from 2 to 2 to 2 to 7. That means for each element in the array, we need to, initially we consider first element as smallest element in the array. Each element in the array from position 2 to 7, we compare with the smallest element and keep updating that smallest element. Is that clear? Now, can you tell me simple algorithm to find this? Whatever procedure we discussed, no, based on this, what is the algorithm? I value varies from 2 to 7. In general, it varies from 2 to 2 to 2 to 2 to n. So what is the condition every time we are checking? What is the condition that we are checking every time? What is the condition we are checking every time? What is the condition that we are checking?
Smallest or not. If A of I is less than smallest.
Less than smallest or not. If this condition is true, if it is true, then what is that we are doing? What is that we are doing? If this condition is true,
Smallest equal to A of I.
smallest equals to A of I. So finally, if we want to return smallest, is that correct? This is simple algorithm to find smallest element. Smallest, what is the other name? Smallest element, it is same as minimum element, no? Minimum element or not? Is that okay? Smallest and minimum element both are same. Okay. So this is the procedure. You tell me what is running time of this smallest element or minimum element finding algorithm? What is running time of this algorithm? What is running time of this algorithm? What is running time of this algorithm?
N minus 1.
What is its order of growth?
N, sir.
What is its order of growth, brother?
N, sir.
N, sir.
N. Its order of growth is N, no?
Basic operations comparison.
Because this for loop, no, this is what is the most important operation? This is the most important operation.
Comparison operator.
How many times this operation is performed?
N times.
So we can take input size as N, basic operation as this comparison. Here number of times basic operation is repeated. It depends only on input size or actual values in the input also.
Input size only. Sorry.
Only input size. How many values are there? That many times we need to check the condition. No, that's all. It doesn't depend on what are the values inside it. It depends
Yes,
on
sir.
how many values are there. T of n depends only on
Number of input.
only on n. Okay. So now what is T of n? T of n can be written as sigma for each value of I 2 to n. How many times it is repeated? One time. What is this value?
N minus 1 plus 2.
N minus 2 plus 1, which is same as n minus 1.
Hmm.
What is order of growth of T of n?
N.
Order of growth of T of n? It is
N.
minus 1. What is order of growth of this? Same as n. Now tell me what is running time of this algorithm? T of n can be written as theta of n. Is this correct or not? This algorithm running time, is it same as theta of n or not? Is it same as theta of n or not? Correct now?
Yes, sir. Yes, sir.
Is it same as, if this is correct, whether this is correct or not? Automatically it is
Yes,
correct.
sir. Correct only.
So that means if we are given n elements, we can find the minimum element in
N.
big O of n time or big O of n time. Big O of n time. So okay. Now one simple algorithm to sort elements is So what is sorted order of this? This is if it is input. What is sorted order? What is sorted order? What is the
output which is
it is 15. Is what is 15 here? What is 15 in the input? What is 15 in the input?
Yeah,
Smallest
7.
element, no? Smallest element, no? Is it smallest element or not?
yes, sir.
So you find the smallest element of this n elements, smallest elements of this given elements, and move it to first position. First position. Is that okay?
Yes, sir.
Correct. Next. What is next element in the sorted order? What is next element in the sorted order?
27.
27. So what is this 27? What is this 27? In the remaining elements, is it smallest element or not? Is it smallest element in the remaining elements or not?
Yes.
What are remaining elements? 87, 43, 66, 88, 27, 32. It is remaining smallest in the remaining elements, no?
Yes, sir.
What is the other name we can use it for that? It is second smallest element I can call, no? We can
Yes,
call
sir.
it as second smallest element. So
Yes,
in the
sir.
remaining elements, you find the smallest and move it to second position. Move it to second position. Now in the sorted order, what is next element? What is next element?
32.
32. So what is this 32? In the remaining element, is it smallest element or not?
Yes,
Is
sir.
it smallest element in the remaining elements or not?
Yes, sir.
Yes. So in the remaining elements, again smallest you find and move it to third position. Again, what is next element? 43
43.
in the sorted order. What is 43? Again in the remaining elements, it is
Smallest.
smallest element. So that is over. Now what is next element? 66. What is this 66? Again in the remaining elements, is it smallest or not? Yes. We keep doing like this. We keep doing like this. After doing this, directly whichever element is there, that I can move it to here, no, last position, no. Again, we need not do anything, no. That itself, one element is there means that is only smallest, no.
Yes.
So like that. So now in order to get sorted order by the definition, what is that we can do? Given n elements, find the smallest element and move it and put it in first position in the array. Okay, first position in the array. What is the next thing that we can do? What is the next thing that we can do? What is the next thing that we can do? That means we are given n elements. We are given n elements. We are finding smallest and moving it to position. Seven elements, for example. So what is step one? What is that we are doing? 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 Find
Minimum.
first smallest element, the first smallest element, and move it to
A of 0.
Okay. So throughout this course, I said I use array indices from 1 to n instead of 0 to n minus 1. Okay, instead of 0, because this is simply confusing. No, 1 to n means counting is easy. Okay, we find the first smallest element and move it to a of 1. Is that okay? Next step.
Yes, sir.
Step 2, what is that we do?
Find
First-
the smallest Find the smallest
find
from
the-
2 to
Find the smallest
from 2 to n.
from A to n and move it to
A of 2.
A of
A
2.
of
A of 2. Okay, what is next step? Find the smallest
A of 3 to
this
n.
and
3
move it
to
to
n.
A3.
3.
To find the smallest in A4 to n and move it to A4. Next, and so on. Find the smallest in A n minus 1 comma n and move it to A n minus 1. A n minus 1. After that, find the smallest in A n and move it to n. That means, is it necessary to do this step?
No.
So now every time, what is that? The same steps we are performing now. Find the first
Yes, sir.
smallest element and move it to A of 1. Next.
Next.
In the step 1, find this smallest element from A1 to n and move it to A1. In step 2, 2 to n we are finding. In step 3, smallest element from 3 to n. In step 4, smallest element from 4 to n. In step 5, smallest element from 5 to n. Step n minus 1, this is step n minus 1. Step number n minus 1. Find the smallest from a n minus 1 to n and move it to a n minus 1. Is that okay? So
Yes,
now
sir.
every time we are following the same procedure. Now finding the smallest element. Finding the smallest element. Other name is minimum element. Minimum element. Smallest and minimum both are same, no?
Yes, sir.
Smallest and minimum. Smallest or the other name is minimum. Everywhere it is minimum. Both are same. Is that okay? Is that okay? Now how to write algorithm for this? How to write algorithm for this? Now whatever code is written here, what is this code? This pseudo code? What is this? Already we discussed. No, what is this? Look at that and tell me what is that?
Finding minimum.
Find position of minimum element.
It finds only position minimum element.
Yes.
Minimum element to the left of I. Okay, no, from I to
N.
n. It gives minimum element of minimum element of a I to n. Is that correct? Like that, how many times I need to do? Like that, how many times we need to do?
N minus 1 time.
N
Minus 1.
N minus 1.
Step 1 to step n minus 1 we need to do. For that, we have taken for I equal to 1 to n minus 1. Is that correct? N minus
Yes,
1
sir.
times we are finding minimum element. But what is the change? What is the change? First time we are finding minimum element of a 1 to n. Second time 2 to n. Third time 3 to n. For that, this I we make use of this I. When I equal to 1, we are finding minimum from 1 to I, j becomes 2 to n. Correct? No. Is it clear or any doubt here?
No, sir.
Now, only if at all you have doubt, this sixth step you will have doubt. Okay? Na? Sixth step will have doubt. For example, this is say 10, this is 8, this is 30, this is 14, this is 5, 6, this is 6, this is 38, this is 24. Now, what is that we need to do? Definitely, we know that 6 is minimum. 6 we need to copy into position 1. Then 10 we lose, no? If I simply copy into position 1 also 6 will be there. Position 5 also 6 will be there. But 10 is required, no? For us, further calculations. For further calculations, 10 is required. That's why what is that we do? We interchange these two elements. We interchange, that is called swapping. We swap these two elements. Is that okay?
Yes, sir.
Is that okay? That's what this code does. It does no, this line does no. Is there any confusion in this selection sort? Now you please, all of you read this and tell me if you have any doubt in this. Consider this part, you please read and tell me if there is any doubt.
Sir, here I have one doubt.
Please tell me.
T of n is equal to n, no? Here, what I am thinking is the number of comparisons we are doing. So if I come from backside, means if I come from the last element, number of comparisons will be, suppose, 1 plus 2 plus 3 up to n minus 1 comparisons. No, sir?
N minus 1 comparison. That's why T of n is n minus 1 only, no?
No, for each element, suppose for the element.
No. This is whatever code I have written, pseudo code I have written, it is for finding only minimum element. It is not algorithm of selection sort, no. This is only finding minimum element. Because this procedure only we do n minus 1 times, no.
Okay.
This is not algorithm for selection sort. This is minimum element finding.
Okay, sir. Just I was thinking, okay, means altogether if it is selection sort.
No. This is entirely different. Before understanding that, we need to understand this now.
Okay, sir.
This is minimum element, finding minimum element. Okay. Now, is there any doubt? That's what we have done now. So this is repeated selection. Every time we are selecting minimum element and replacing that with respective elements. First time, first element, second time, second element, third time, third element, n minus 1th time, n minus 1th time, n minus 1th position. After that, only one element will be there. That will be automatically in nth position. Is that correct? This is called selection algorithm. Okay, now selection sort algorithm. What is that we are selecting here every time? Finding minimum.
Minimum element.
Minimum element only we are doing n minus 1 times. Okay, in different subarrays. Now, what is running time of this algorithm? What is input size? What is parameter indicating input size?
N.
N. What is most important operation? If we have any confusion, you can calculate for all steps. You can calculate for how many times this step is performed. If there is a confusion for you, you can do it for all. How many times this step is performed? What is this value? What is this value?
N minus 1.
N minus 1.
1 minus 1 plus 1, which is same as n minus 1. How many times this step is performed?
N minus 1 time.
For each value of I, it is performed, no? So this is also performed sigma I equal to 1 to n minus 1, 1, which is same as n minus 1. Tell me how many times this step is performed? How many times this step is performed? For each value of j equals to I plus 1 to 1 n, one time it is performed. But this entire j step, it is below I know. So instead of using braces, okay, I use indentation. Okay, now I use indentation here. Okay, for each value of I, this part is repeated. What are the values I takes here? 1 to n minus 1. Is that correct? This many times third step is repeated. You tell me how many times fourth step is repeated? How many times fourth step is repeated? How many times fourth step is repeated? Same as step 3. Is that correct? Same as step 3. Whenever step 3 is performed, automatically this condition should be checked. Whether it is true or false, that is different. But definitely this condition should be checked. No.
Yes, sir.
How many times step 5 is repeated?
Minimum position means 10 times.
So, sir, it depends on the result of logical expression.
It depends on actual values in the input. It depends on actual values in the input. Are you getting it? Why? Because, okay, I can give you an example if you have any confusion. For example, if you have any confusion, if you have any doubt, you can tell me. Okay, now, suppose I have a value 1 to n minus 1. Okay, now suppose I have a value 1 to n minus 1. Okay, now suppose I have a value 1 to n minus 1. Okay, now suppose I have a value 1 to n minus 1. Okay, now suppose I have a value 1 to n minus 1. Okay, now suppose I have a value 1 to n minus 1. Okay, now suppose I have a value 1 to n minus 1. Okay, now suppose I have a value 1 to n minus 1. Okay, now suppose I have a value 1 to n minus 1. Okay, now suppose I have a value 1 to n minus 1. Okay, now suppose I have a value 1 to n minus 1. Okay, now suppose I have a value 1 to n minus 1. Okay, now suppose I have a value 1 to n minus 1. Okay, now suppose I have a value 1 to n minus 1. Okay, now suppose I have a value 1 to n minus 1. Okay, now suppose I have a value 1 to n minus 1. Okay, now suppose I have a value 1 to n minus 1. Okay, For example, my input values are 10, 20, 30, 40. N equals 4. How many times this step is performed? In this case,
Not going to perform 0 times.
how many times? This is 0 times.
Hmm.
In this case,
3 times.
3 times. That means for same value of n, is it different? Is it different or not?
Yeah, yes, it will.
Input size. That means it not only depends on input size, but also actual values in the input. Then we get doubt. Sir, if that is the case, then we should go for best case, worst case, average case. That doubt we get now. Okay, we'll come back to this step. Okay, after completing step 6. How many times step 6 is performed? How many times step 6 is performed?
N minus 1 time.
For each value of I, this step is performed now. For each value of I, it is performed. That means sigma I equals to 1 to n minus 1 one time, which is same as n minus 1 times. Is it clear? Except to step 5, everything is clear to us now. Except to step 5, everything else is clear now. Is that clear or not?
Yes, sir.
Okay. Now we get doubt. Now, do I need to go for different cases or not is the question. That's what the doubt we get now. Do we need to go for different cases? That's why we actually talk about the most important operation, which actually decides order of growth of running time of our entire algorithm. Out of these two operations, this operation and this comparison operation, which operation will be repeated more number of times out of these two? Which operation will be for given value of n, any value of n, out of the two, which operation is performed more number of times? For any input size,
Comparison.
any instance. Because here it is in condition statement. No, if it is true, then only it is performed. Even if it is false also, this condition we need to check now.
Fourth step will execute.
Whether condition is true or not, fourth step is executed. Fifth step is performed only if the condition in fourth step is true. That means we know that definitely in this method, this step is repeated more times than step 5. Is repeated more times, is performed more times. Is that correct? If that is the case, then why should I bother about this step? What is the number of times it is performed? It is immaterial to me now. Because this is definitely not more than this. It is not more than that. Then why should I bother about this step? But we can easily say, what is the minimum number of times it is repeated? If input is like this, how many times it is repeated?
0.
If input is like this, how many times it is repeated?
0.
No. If input is
One.
second input, 3 times it is performed, no, that operation.
Second one is.
Every time that condition becomes true, no. But whatever it may be, this value is not more than this value. Hence, we need not even bother about this line, that operation, no. It is not going to determine what is the running time of algorithm, or neither it is going to affect the running time of algorithm. Is that okay? Is that clear? Now, is there any point in going for best case, worst case, average case in this scenario situation? Is it necessary to go for best case, worst case, average case in this scenario?
Not required.
Not required, no. What is the use? It is not going to determine algorithm's running time, no.
Yes.
So you simply ignore it. We can only say that it is not more than number of times operation is performed in step 4. Number of times operation is performed in step 4. Is that okay? That means you tell me which is most important operation in our algorithm. Which is most important operation in this entire algorithm, means which operation is performed more times, that becomes our favorite operation, no? Clearly, this is our favorite operation, no? So this is comparison operation. Is it okay? Is that okay?
A of ij, okay.
Let T of n be the number of times comparison operation is performed. Operation is performed when n is input size. This we have been writing, no, every time. Input size. Now you tell me, we know that T of n depends only on n or actual values in the input also. Only on n. Then there are no best case, no worst case, no average case. Now you tell me, what is T of n value? What is T of n?
Order of n square.
That means how many times this operation is performed? For each value of j, I plus 1 to n, one time it is performed. But this entire thing is performed for each value of I,
1 to n.
1 to n minus 1. Is that okay? Now we need to simplify this. We need to simplify this. So therefore what is step 4? What is T of n? What is T of n? What is T of n? Sigma I equals to 1 to n minus 1. Sigma j equals to I plus 1 to n 1. You tell me, what is this value? What is this value? We have used it many times, no?
I equal to 1 to n minus 1. 1 to n minus 1.
No, what is value of this circle expression?
Minus I.
N minus I, is this correct? N minus I plus 1 plus 1. So it becomes n minus I. Now what is this value? What is this value? If I equal to 1, what is this?
N minus 1.
I equal to 2. Okay.
N minus 2.
This is n minus 1, no? Oh, yeah, plus
okay.
1.
Okay.
Okay.
It is n minus 1.
So what is this value? If you are, one way of doing is substitute I for each value and determine. Otherwise, okay, I equal to 1. If I put, what is this? N minus 1. I equal to 2, I n minus 2. And this one, what is the maximum value? I equal to n minus 1. Then it becomes n minus 1. Is that okay? This is I equal to 1 case, I equal to 2 case, I equal to n minus 1 case. What is this entire value?
N minus 1
by 2.
Plus 1. So this is n into n minus 1 by 2. This is one way of calculating. What is the other way? What is the other way of doing it? That also we discussed, no?
Separating both, sir.
We can split it and apply to both, no? T of n can be written as sigma I equals to 1 to n minus 1 n minus sigma I equal to 1 to n minus 1 I. So here n is independent of I, we can take it outside. It becomes sigma I equal to 1 to n minus 1 minus, what is this? It is sum of first n minus 1 terms, no? N minus 1 natural numbers. Is that okay? What is this value? This is n into n minus 1 minus n into n minus 1 by 2, which is same as n into n minus 1 by 2.
Let's say.
Is that correct?
Order of n square, order of n square. Yes, sir.
Is it okay? So both finally T of n is this. Now what is the order of growth of T of n?
Order of n square. N square.
Only n square. Only n square. Now what is this T of n, which is nothing but running time of selection sort. No, what is running time of selection sort? It is big O of n square. Is this correct or not? Is this correct or not? Running time is here. What is there after this? What is its order of growth? Only n square. N square is big O of n square. Correct or not?
Yes, sir.
You should not think even a second now. Okay, no, to answer this. It is n
Yes.
square is big O of it is correct. No.
No.
Running time of selection sort is big omega of n square. Is that correct? Is that
Yes, sir.
correct?
Yes, sir.
Yes, sir.
Running time of insertion sort is theta of n square. Is that correct?
Yes, sir.
Yes, sir.
Now you can play no. So if somebody gives like this big O of n cubed, is this correct? Running time of insertion, selection sort is big O of n cubed. Is that correct?
Yes, sir. Yes, sir.
You cannot say that it is wrong. No, it is also correct. But
Yes,
nobody writes it this way.
Oh.
Even if I write it as big O of n factorial, is it wrong?
No, sir.
Please don't remember these answers. Okay, I kindly request you not to
Okay,
remember these answers. Once you know that its order of growth is n square, you can play with asymptotic notations however you want. Okay, no, you can represent its running time infinite number of ways. No,
Yes, sir.
it's not that running time of selection sort is theta of n square, running time of selection sort is theta of n square. It's not memorizing like that. No, are you getting?
Yes, yes.
That is my intention. You should not remember. You should be able to understand and tell why they have written like this, why they have written big omega way, why they have written theta of n square. All are correct. Anything is okay. Even if they write it like this also, it is okay. But it gives always upper bound. Why upper bound should be as small as possible. No, this is smaller. So this is better answer than
Yes,
this.
sir.
So
Order of
this
n.
way,
Yes.
unnecessarily why to write it this way? If you write it is not a crime, but no need to write no unnecessary confuse.
Yes, sir.
Is it clear? Now tell me what is best case running time of selection sort? See, once you know that its
N, sir.
order of growth
Best
is n
case is-
square, then there is no best. Okay, its input now depends only on input size whether there is best case.
Here
Worst
no
case,
best and worst cases, sir.
all are same. Only one case. That case order of growth is n square. And answer, if you want, you can write it as theta of n square, theta of n square, theta of n square, like this. Or actually, these are not required. Correct? No, in this case.
Best are
Sir, when it
same.
is depend upon elements means there is no there's no need to check, sir.
But still there is no change, no brother.
Yes, sir.
What is your point that I have understood? That is here minimum position is j. How many times it is repeated? No, it depends on actual values in the input. Are you getting?
Yes, sir.
Yes, sir.
But why we are not bothered about this operation? I said no, because if it is true, then only this operation is performed.
Yes, yes.
That's why no need to. Nobody asks it this way. Even if asked, also answer is same only.
Okay, sir.
Okay.
Best average
It is
and
not.
worst.
It's meaningless here. Okay. Now you tell me what is the amount other than input. First input should be given to us. Array A, no? Array A is given. For that n memory locations are required. Array size is n. So what is the total amount of memory this algorithm takes? Array A means here n units of memory is required, no? N units of memory. Other than that, variable I variable 1 unit. Okay. What minimum position? This also 1 unit. J variable 1 unit. What else we are using? I think that's all, no? Again, you may ask, sir, how to do swap? How to swap this? Swap function A of I, A of J. A of I, A of minimum position. How to swap this? How to swap this two? Again, if you want, we can take one temporary variable, temp equal to A of I. A of I equals to this is standard, no? Is that okay? Is that correct? Okay, instead of writing these 3 lines, I have simply written here swap. Is that correct? Here also, this is one variable which you may use. So that also you count
Yes,
it
sir.
1. So total, how many units of memory? How many units of memory?
3.
N plus 1 plus 1, 4 times or 3 times or 5 times or 6 times, it doesn't matter, no? So now amount of memory is equals to N plus some constant. I can write N plus 3 or N plus 4 or N plus 2, okay? N plus some constant. So that means what is its space complexity? What is its order of growth?
Order of
Same
n.
as N. So now what is space complexity? If I write it as theta of N, is it correct? Is that correct? If I write it as big omega of N, is that correct? If I write it as big O of N, is that correct? Is that correct or not? How much space we require here? How much space we require? How much space we require here total? N plus 4 units or 3 units or 5 units. That simply I call it as N plus constant space. Are you getting, or is there any confusion? Is there any doubt? Hello?
Yes. No, sir.
Oh, okay. Thank you, brother. So now what is space complexity of this selection sort algorithm? You can say that it is theta of N or big omega of N or big O of N. Okay. Now, other than input, what is the additional memory that is required here? Space or additional memory other than input. What is the additional memory other than for array A? How many units of additional memory you require?
Constant, sir? It would be constant?
It is constant. Why 4 units or 3 units or 5 units or 6 units or 7 units or 10 units or 20 units? But definitely it is not depending on N. No. It doesn't depend on N. No. It is independent of N. Additional memory is constant. It is independent of N. Is that independent of N or not? Okay, and a constant means what? We can write it as order of growth is N power 0 order of growth. That means what? We can write it as additional memory required is big O of 1 or big omega of 1 or theta of 1. All these are correct or not? Amount of additional memory other than input that is required is theta of 1 or constant. Is that correct? Is that correct? Is that correct or not?
Yes, sir.
Okay. If any sorting algorithm, if the amount of additional space required other than for the input, if it is constant, that type of sorting algorithm we call it as in-place sorting algorithm. Now you tell me, is it in place or not? What is in place? What is in-place sorting algorithm? When do you say that a sorting algorithm is in place?
What, sir?
In place sorting algorithm. What does in place sorting algorithm mean? If the additional memory required is constant, then we say that is in place sorting algorithm. Now you tell me, is selection sort in place sorting algorithm or not? Is selection sort, is it in place sorting algorithm or not?
Sir.
What is the other than input? What is the additional memory it requires? Other than input, what is the additional memory it requires?
For swapping. Temporary.
No. How many units of memory it requires? Other than array A, how many units of memory it requires?
Only one unit.
It is constant depending on implementation. It may be 5 variables or 6 variables or 7 variables or 10 variables or 20 variables. Definitely it is not 2 times n or 3 times n or 4 times n by 2 or half of n by 2, half of n, that is n by 2. Not like that. No, it is independent of input size or not. Is it independent of input size? That means in place means they sort the elements without requiring much of additional memory. They require only small amount of memory that is not depending on input size. That's why selection sort, is it in place algorithm or not? Is it in place sorting algorithm or not? Is it in place or not?
In place.
In place. Okay. Now, if at all we are counting how many times this operation is performed, how many times minimum equals to position j, how many times this operation is performed? Can you tell me that count? It is not going to affect running time. For only curiosity purpose, you tell me how many times minimum position equal to j that operation is performed. If n elements are given, how many times that is performed?
Less than n.
No, see, that is only one loop, it is less than n, but overall, for all n minus 1 steps. Okay, that I leave it to you. Okay, now you calculate. Okay, maybe similarly, other algorithms also, I'll give some tasks like this, sorting algorithms, that we will discuss later. Okay, you please count and write in a sheet of paper and keep it with you. Okay, that we'll discuss later. Okay. So now we'll break for half an hour. Then 6:30 again we'll continue.
Okay, sir.
Okay, thank you.
Yes, sir. Thank you, sir.